Right, so let me try and illustrate how we're going to use maths to estimate the height of this tree. So if we got our tree here, and there's our flat ground, what we don't know is how high that tree is. And we can't measure it. But what we can measure is the distance from the base of the tree to a position where we're standing. Now, how that is going to help us is we are going to move away from the base of the tree and we are going to look upwards at the height of the tree. So we're looking upwards to the top of the tree, and that's going to turn through an angle. Now that angle there, we could make that into a rectangle. That's quite a steep angle, and you can see that the distance we are away from the tree is shorter than the height of the tree. So we've got a rectangle. As we move further away, so as we change our position, as we walk further in that direction, let's say we end up here, as we are now looking to the top of the tree, that's a straight line, honestly. If we consider this triangle, that angle now is a lot less than the angle there, because we don't have to look up so sharply, and we can measure that distance by pacing that out. And again, what we would have here is a rectangle. The distance we are from the tree is a lot further than the height of the tree, than this side of the rectangle. So somewhere in between these two positions is a point where we are going to be the same distance away from the tree as the height of the tree. That would be where we've got the sides of a square. And that angle is the crucial 45 degrees. So when we pace away from the base of the tree, and we get to the point where the angle that we're looking up is 45 degrees, then we're at a position where the distance we have walked away from the base of the tree is the same as the distance from our eyesight to the top of the tree, because we've created a square. Now another way I can illustrate that is if you take a rectangle. Okay, so this piece of paper is A4, it's longer than it is wide, and if I was to join the diagonals of that, so if I was to fold across the diagonals, that doesn't match up. But if that was a square piece of paper, then we would get a perfect fold. Now on our A4 piece of paper, the way that I can demonstrate that is by folding it so that I match the opposite sides together. Okay, so what I've done there now is create a square. The length of this side to the fold, so the fold was there, that length is 21 centimeters, and if I measure the width of the page, it is also 21 centimeters. So if I take my rectangular piece of paper, my A4, and fold it so that the opposite sides match, what that then gives me here is a 45 degree angle. So what we are going to do is we're going to make out of some paper this 45-degree angle. So I'm going to just get rid of this bit that I don't want. So I've now created a square piece of paper, and what we're going to do is when we find our tree, we're going to walk backwards away from the base of the tree with this lined up against our eye, keeping the base, the bottom of it flat, horizontal, and keep walking backwards until along this line of paper I can see the top of the tree. So when the top of the tree is there, then I know this is square, which means that's 45 degrees, and the distance that I am away from the base of the tree is the same as the distance from my eyesight, my eye line, to the top of the tree. We can then measure that distance by pacing it, and that gives me the distance here, D, and then I just need to find out how high above the ground I was holding that triangle, and then I, E for I, and then we can add those two together, and that'll give us the height of the tree. So that's a really easy way of estimating the height of a tree. You create a 45-degree isosceles triangle, it's called, because that side and that side are square, they're the same length, and we can then use that. We measure one pace, so how far, what distance do I have one pace when I step, usually approximately a meter. Count the number of paces, let's say it's 10 paces, so that would be 10 meters from the base of the tree to where I'm standing. So the height of the tree would be 10 meters plus the height, the distance from where I'm standing to my eyes. Okay, so that's what we're going to have a go at.